Okay, so this problem is a little bit trickier than normal. This it says that we are looking for the volume of the solid obtained by rotating the region between y equals x squared and x equals y squared about x equals -1. Okay, so I'm going to draw this with pencil so that I can show you guys what's going on. Well, first of all, let's just draw the curves themselves. So this one I'll do with a pen. So here what we have is this is going to be y equals x squared. So that's a parabola. It looks like this. And then x equals y squared. Looks like this. So these guys continue, and this one continues, and this one continues over here, and this one continues over here. But the region between them is this area right here. And now this is different than usual because normally we would rotate it around the axis, and so it wouldn't be as big of a deal. But now this one, we have a small situation, is that we're rotating it about x equals -1. So if you're rotating it about here, then what ends up happening is we end up with a situation where we have kind of like a washer, because okay, so let me try to draw a good picture here. Okay, so we have here, this is my region. Okay, and then here's the line y is equal to -1. And so if I rotate this around here, what I end up with is I have a wider, so then I rotate this around, and I end up with kind of like a I guess you could say it's kind of like a bowl with an open bottom, right? And so this would be kind of filled in. So you rotate this around. But now, how do you figure this out? Well, let me show you kind of what's going on. Is that if you grab the if you graph the let's do this in stages. Let's say you graph the outer function. So this would be just y equals x squared about x equals -1. So let me just show you what's going on. So this is what I want. So I already have a picture in my head. So let's erase this real quick. So let's say I draw the solid obtained by rotating y equals x squared about x equals -1. So here I would just get this entire region if I draw just y equals x squared. Okay, but then if I then take away x equals y squared, if I take this away, what I end up with is a washer with just the surface that I'm looking for, just the outside part. So then my strategy becomes, okay, well, if I could find each one individually, so the surface of revolution of this guy and then take away this one, then that should give me exactly the surface that I'm looking for. So that's going to be my strategy to go about solving this problem. Okay, so then I need to figure out how I'm going to go about it. So it looks like the easiest thing to do would be to integrate with respect to y. And so my cross sections would be disks. I would have, well, that would have the inside cross section. That would be the, for the inside cross sections would be for x equals y squared, and then I would have my outside cross sections. That would be for y equals x squared. So those would look like this. And again, the idea is I'm simply going to subtract the two. So these cross sections, well, we need to figure out. Well, I know they're disks. They're the areas of them are circles. Okay, so now to find the equations, let's do the purple one first. So the purple surface, the area of the purple cross section, is going to be pi times the radius squared. Now the radius is equal to, notice that from here, where you rotate it about, and the origin, that's 1. So it's going to be 1 plus the x value from here to here, which for the purple one is going to be square root of y. Because y equals x squared, so x is equal to square root of y. And x gives us the length from here to here. Okay, and then for the green one, the area is pi times the radius squared again. But now this time, the radius is 1 plus y squared. Because now I have it in terms of y already. Okay, so now I can set up my integral because I know that the volume is, we already talked about it, the volume is going to be the integral. Since I'm integrating with respect to y, I'm going to go from 0 to the very top, which is 1, of the purple cross section minus the green with respect to y. Okay, so then what I have is, if I, since they both have pi, I'm just going to take out the pi. So the integral from 0 to 1 of pi times 1 plus square root of y squared. Sorry about that. The pi shouldn't be there. Minus the green one, which is, almost did it again, 1 plus y squared squared. And then all of this with respect to y. Okay. So we have quite a bit of math to do. Why don't I break this whole thing up? I'm going to write this all out. So this is going to be 1 plus 2. Instead of square root of y, I'm going to write it as y to the 1 half. And then I have plus square root of y squared, which is just y, minus 1 minus 2y squared minus y to the 4th. And all of this with respect to y. Okay, so notice that the 1's cancel, and there's nothing else I can combine, and so if I get the antiderivative now, what I'm going to get is y to the 3 halves times 2/3, and when I multiply by that 2, I'm going to get 4/3. And then plus 1/2 y squared minus 2y cubed over 3 minus y to the 5th over 5. And this is going to be evaluated from 0 to 1. And this, when you simplify all this out, you should get 29 over 30 pi. And that's your answer.